Intro Algebra Lesson 4-1A. We're now going to switch gears a little bit away from the equations and start thinking about graphing. Eventually we'll incorporate the two, but for right now we want to make sure we have a good solid foundation when it comes to graphs and making graphs. So to begin with, when we talk about a graph, one of the main things to think about is a coordinate plane. And a coordinate plane is really made of two real number lines that intersect at a right angle. Right angles are 90 degrees. Now, number lines have positive values and they have negative values, and then there's usually 0 that separates the two. But if we're going to have two of them, they can't run parallel to each other, so they would look more like this. This black line is a number line. And to the right, you would have values that are positive. And to the left, you would have values that are negative. Well, there's another number line that's going vertical, and the numbers that are going up are positive, and the numbers that are going down are negative. We also refer to this line, this number line, as the y-axis. That's the y-axis. And we refer to the horizontal line as the x-axis. One other piece of information to note is that right here, where the two number lines cross, is actually the value of 0 for both number lines. Because if it's positive up and negative down, 0's got to be in the middle. If it's positive right and negative left, 0's got to be in the middle. So this actually is a very special coordinate. It's known as the origin. And if you think about the word origin, it sounds an awful lot like originate or original. Original meaning it's the first one or the start. It began it all. Where something originates is where it's from. We will always start at the origin when we make our graphs. I'll speak a little bit more about the origin and its specific coordinate. When it comes to ordered pairs tell a very specific location for an exact point on the coordinate plane. Now the word order means that it actually matters the order we use. And pair means that there's two. This is the ordered pair. And it must always be in the order that x comes before y. If you're thinking to yourself, I can't remember whether x comes before y, think of the alphabet. X always comes before y in the alphabet. And there are two pieces of information in this ordered pair. So order is important, x before y, and there's two parts of it that create the coordinate itself. Some might say, well, how come it can't be y and then x? Why do I have to always follow that ordered pair? If we didn't all follow the same ordered pair, it would be possible that some people would be using it one way and some would be another. We wouldn't be talking about the same coordinate. So we need to all be on the same page, and that's why there was a rule established. So again, I have this same coordinate plane. It looks the same as before. And I just want to look at a couple coordinates. 7, 5. Now, there's a possibility that somebody might make a mistake with 7, 5. Now you'll notice there are two parts of this ordered pair. The number 7 represents the x, and the number 5 represents the y. Okay? Some people will come over here, and they'll put a dot right there. Other people will put a dot right here. They both think they're graphing 7, 5, but only one of the points is correct. Remember, it tells a very specific location of a point. So if it's a very specific location, it can't be one or the other or both. It has to be only one of those. And the key lies in this order. The first number is a 7 represents x, which means I always start at the origin. Remember I said that's where we should start? And from that origin, it's telling me that my x value is 7. So I will go to the right 1, 2, 3, 4, 5, 6, 7 places. I'm not going to put a dot there because I'm not done. I then have a y value that's positive 5. So from there I should go up 1, 2, 3, 4, 5. So this is actually the coordinate 7, 5. That is the right spot. This coordinate is at 5, 7. Now you can see that makes a big difference. It's not off by a ton, but what if the numbers were larger? You could really be far away from where you should be. So coordinates are important that you pay attention to the ordered pair. If it were negative 7, 5, we would still start at the origin, but we would go left 7 because it's a negative x value. Left 7 and up 5. And if both values were negative, we would start at the origin as always, and we'd go left 7 and down 4. So this is like a map. It tells you exactly where you need to go. Start at the origin, go right or left according to this number, up or down according to this number. Now you recall, I said that the origin is where we always start, and it's 0 for both of the number lines. So it's a very specific coordinate. 0, 0 is right here. That's the origin. The origin always starts at 0, 0. So when it comes to making graphs, you must follow this. I will point out one mistake that I see quite often. Somebody sees 7, 5, and they think they're going to graph it, so they put a dot here, and they put a dot here. And they think they've graphed 7, 5 because they put a 7 on the x, and they put a 5 on the y. And I understand the logic, but remember, this coordinate represents exactly 1 point. That's it, just 1 point. That's 2 points. You can't get away with using one coordinate to produce 2 points. You must be careful of that. Alright, when it comes to graphing, that's the actual act of placing the points on the coordinate plane that correspond. Correspond is a fancy word for matches. So placing a point on the coordinate plane that corresponds or matches to an ordered pair. When I had this data here, these points were given, I placed dots on the coordinate plane according to these values. That was the act of graphing. Alright, and lastly we have what we call quadrants. Each one of our graph, our coordinate plane, is broken up into quadrants. Just like when people ride their quads, they have 4 wheels. There are 4 sections of the graph. The top right is always referred to as quadrant 1. These are Roman numerals. Quadrant 2, quadrant 3, and this is quadrant 4. Any coordinate that is in this quadrant, I'll tell you right now, the x value will always be positive, and the y value will always be positive. So I know that doesn't look straight. I'm saying positive values. Both your x and y will be positive if you're going to be in quadrant 1. If you're in quadrant 2, your x value has to be negative to bring you left, but your y value has to be positive to bring you up. If you're going to be in quadrant 3, both the x and the y are actually negative. And if you're in quadrant 4, the x value is positive to bring you right, but your y value is negative to bring you down. Okay? So let's say I have this dot right here. This dot is in quadrant 2. This dot's in quadrant 2. This dot's in quadrant 4. This dot is in quadrant 3. This dot is in quadrant 1. Now that's pretty easy, but here's where it gets tricky. Which quadrant is it in now? Some people say it's in quadrant 1 and 4, when in actuality it's not in a quadrant. You would say it's on the x-axis. And if it were up here, it's not in quadrant 1 and 2, it's on the y-axis. And if you found it right here, you could say it was on the x and y axes, but it's easier to state that it's on the origin. The point is on the origin. So, if it's fully in one of the quadrants, then you can name that. A point can't be in 2 quadrants at the same time. Alright? Just want to make sure I reiterate real quick that the ordered pair is always x followed by y. Positive x's are to the right, negative x's are left, positive y's are up, negative y's are down.